Okay, hi everyone. Today is create secure hash algorithm with 32-bit in Excel with formula. So I got the inspiration from my previous challenge from Thomas Marcelo. So this is his challenge about the first person shooting, but I'm interested in this one. So he used secure hash quality 6 no 256 to transform this text into this form, and then I quite curious about this one. So this is how I got started, and then Google out, I found this document from where National Institute of Standard of and Technology, and this is the one skill hash standards. And since I done this one before, so I got some foundation of knowledge about this one. So this is what I did before with another kind of hash which is called MD5. So this one, and this is the formula I use in that one. Don't terrify by this long formula, because most of this one is what it say, a constant, which is some kind of set of number here. So I'm gonna walk you through this document where honestly I'm really bad at reading, but I got something out of this, and then when I'm stuck, I still have Thomas function here to help me. So okay, and this is the file I've done this one, and they all have the link here. Okay, so I'm just gonna start by following this document here, and then so this is already done, so I have a backup plan here. I think I'm gonna use this one because this is like quite too long to do this. So okay, start by this. They have some. This is 36 page. Okay. Oh, that's it. So okay, so there are like this document, we have different kind of hash. So but the one I'm gonna do here is like 32-bit, because 62-bit is too long for doing Excel. So like, okay, so first, this is the maximum number for 32-bit, which is length 10 digit. This is possible, but 64-bit is too much for Excel to handle. And then like, so this is power 19, and the length of this one 20 digit. So this is like the maximum precision on Excel is only 15, so the rest will return 0. So I have to go number here. Wait, out 2. So see, the rest of the number after 15 digit is only show 0. So that means I cannot use number method to do this 64 digit. So I'm gonna skip for this one, and we'll maybe try. I'm not sure because I got a lot of stuff to do with this residual, so I'm not gonna do this 64 digit today. Okay, so continue. We have some term, and we have bit, which is 1 and 0. We have byte, which is 8-bit, and some here. And then there are a lot of parameter here, which is like quite headache to read it. So okay, but you can look back at this parameter later, but the most important thing is this one, the operator. The first one is bitwise. Okay, I'm just gonna grab some number from this one. Wait, a lot here. Okay, so we use this one. This is used for 256 and 224, so I'm gonna use this one. Copy this, and then gonna extract all this. So regex extract this one by any number or alphabet. Which one got what? Oh, wrong cell. Okay, and then to call. So these are constant. There are some meaning from like prime number, square root, and cube or something, but I don't mind that one. So this one can turn into decimal number, which is I can go with hex to dex with all this. I need plus sign. So this is hexadecimal number, and then another function that can do is decimal. This one, but I have to tell this is 16 digit, 16 bit. So these are all the same. And then this bitwise is operate on binary, which is 0 and 1 only. So I have to turn this one into binary, which is this one. I can go with binary dex to bin. No, bin to no, dex to bin is correct. Dex to bin on this one. It's got none because it's only limit to like I think 8-digit number or some kind. I cannot remember, but when this is fails, I have to use decimal. No, binary, right? What? By no, I forgot. Oh, the function is base. I forgot this one, and then I want to turn this one to base 2, and then for some length I start with 8. I think it's not enough. No, not enough. Okay, this is how many digit? Blend this one. 8 digit for base 16. That means I need 64 for this one. That's gonna be too long, I think. Okay, I'll just get rid of the digit. Batch sample. Okay, I'll start with small number. So okay, 1 2 3 3 4. Okay, just start with small number with this one. And I need some fixed digit. I think I go with 16 first. Okay, smaller one. So I'm just gonna start with this bit. Where is it? Where? Okay, bit and. So bit and is the operation that we check each digit of two number, and then if all are 1, then we return 1, and then if all are 0, no, all are 1, return 1, else return 0. So I can go, Excel have some this bit and operation already, so I go with, but this deal with number, not binary. So bit and with this two we return this number, and if I change this one to base, we can see that I think go with some mono. So that means each number have the same space. Okay, so this digit, okay, this one only 1 and 0, so like only 2 1 return 1, so this 2 1 return 1 here, and so at the end we have to compare like this, but Excel have this one, so I'm gonna use this one instead. So this is bit and we have this one, and then there are, okay, this is, we have bit or, which is this side. So bit or on this two, which is the same, but or will be like only only one of 1 is return 1, so like just or 1 true is or. So this mean it's almost the same. So 1 of this and 1 of this, 1 of this, so only both 0 return 0, so this is bit or. And then XOR, which is we check if only odd number of true, which is this digit, so this one will return 1, and then 2 1 is false, so this 2 return false. So we have all this, so this is bit XOR. So you can see that 1 1 0 and 1 return 1, 0 and 1 return 1, 1 and 1 return 0. 1 and 0, which is 1, return 1 here. Just go like this. And this complement, this is another name of bit not, which is, we don't have that one in Excel. So bit, we don't have bit not here. But this one is just like we switch the number. So that means 1 will be 0 and 0 will be 1. So that means I can go like, how many digits of this one? Oh, I cannot do that because this one is 16 digit. Okay. So just gonna type in, so 1 here, and then this is 0 0 0 0 1 0 0. So this is like, and then if I go with base decimal from this one, base 2 is will return this number. So we can see that there are some relation with this number, which is if I add these two together, I got this number, and this number is 2 power 16 minus 1. So this means if I go with this symbol, I don't know how to type this one. I don't know. So bit not, okay, just type in. Okay, this is, I think I cannot copy this one. Okay. So bit not, and the SOR here, this means I need to know the number of digit, which is now I use 16. So it means I go to power 16 minus 1 to get this number, and then minus this number to get bit not, and then just this one is just swap 0 and 1 here. Okay. Then there are shift, left shift, which is we also have this one. So if I go bit L shift, yep, bit L shift with this one. How many? If I go to, I got this number, and oh wait, let's go with all here. And if you can notice this one, so we add 0 to 0 at the end here. And then if I keep continue, oh wait, if I continue from this one, we just like, we multiply by 2 power 2 on this one. So I mean this one multiply by 2 power 2, I got the same number here. I mean I can use this function, or I can use just multiply by 2 power by that number. But at some point, when number is like too much, okay, just if I go for more, like if I go like power 8 here, okay, go with 8. At some point it will cause num, because the number is exceed what Excel can calculate, but I still can do the multiply. So it mean this one I power by 8 here, power by 8, so I can still like go some more with this number and without causing error here. But at some point when it exceeds this one, the remaining digit becomes 0, so I'm not gonna use that. So it means this number will get over 15 digits significant at some point, so I want to limit this one. And the way to limit that one, like if I want to keep 16 digits, I have to mod this one by 16 digits. So I can go with this one, mod by 2 power 16. Oh, it costs number. Okay, I grab some number else here, copy and Control Shift V here. So at some point it will exceed 16 digits, and then I can mod this one by 2 power 16 to limit. Still cannot be too much. I don't know. 32. Okay, just should I do this? mod. Okay. Oh, I know, because the number is just like 16, because it cancel out. Okay, I have to go with some more, because I multiply this one by 2 power 8, I mod by 2 power 16, so this the number is cancel out to be 0. Okay, so okay, let's start from this. If I mod it here, 2 power 16, oh, 0, because I power by 8 here. Okay, let's go by 15. Go with this one. No, okay, power by 20. This one cost num 32. Okay, so this one I limit number to like 32 bits or some kind. So I have to like limit some number on this one. So that will not cause the number to be num, because I limit this, so I can like go on forever for this one. But without the mod, at some point I will get num, and then I cannot calculate further from this one. So this is bit left here, and then bit right is almost the same, except that I shift all digit to the right, and this is the same as divide by number power by 2. So this means, so bit shift will be this one, 2 digit. So I shift number by 2 digit to the right here, and then I get rid of the last digit. So I mean at some point it will just show 0. So if I go with normal operation, which is just this one, will only be like this number divide by 2 power 2, and then if there are some residual, I don't want that one, so round down or in it out. So it mean, so this is a bit chip, right? And then there are some function here, which is rotate to the left, rotate to the right, which is combination of bit L shift, and this V is what is this V? Bit R on the bit shift right on W minus N, and then when I go with 32 bit, this W is 32. Okay, so and then similar to the shift rotate right and this one, and then there are shift by X and N, which is just like shift right. Okay, so this is okay, so this is some operation. Then this is how they in, let's say, bit string and integer. So we use the unichar of, oh no, this one is just, this is almost the same as I do it here, but I done it in decimal number. This one is returning hexa 16 base into binary base 2. Okay, this is how they calculate. And then there are some writing here, which is quite important. There are always do this one, bit and bit or, and then we have to do that modulo, which is mod 2 of that number, so 2 power by 32 here. So every operation require this one. And then bit shift right, it's just go like this, bit shift left, and then we have rotate here, not the same. And then they say rotate left equal to rotate right by W minus N, almost something here. Okay, and then I'm gonna start with 256 here, and this, all this function required to use in 256, all this, so we have to do this rotate many times, rotate. So it's better to have this rotate function or lambda, and then there are ch, which is x and y, and then xor with bit not of x and z here, and then there are some all this together. Okay, so this is xor. Oh, okay, so this one is start with constant, which is already here, and I turned this one to decimal because this Excel function can deal with decimal. So this is the k, which is constant from 1 to 64. We have 64 row, but this number is start from 0 to 63, which is almost the same. And okay, this is too much. So we start with pre-processing, which is we change this one into code of some ASCII number, ASCII code, which is Unicode function. So okay, I'm just follow by this sample here. So where should I start? Okay, start it new one. Okay, so we have A, B, C. We need Unicode of each one. So let text to be this one, and then I'm gonna need Unicode. So Unicode of text. No, I need to split each. So mid text by sequence. Length txt by 1. Got Unicode of this, and then I have to turn this Unicode into binary. So this should be base of 2, and then we need 8-bit here. So 8-bit here, go like this, and combine together, concat. So I got this one, and then we require this one to add some number here, which is number 1, and then number of length of this one in 62-bit. So this means from this one I got binary here, bi, and then this is bi. Okay, and with this bi I need to add number 1 here, which is okay, the calculation of I have to add so many 0 here, and then that many 0 is calculated by this number. So L plus 1 plus K equal to 448. So if I calculate this one, so I need L. So L will be length of BI. And this number, which is K, will be equal to 448 minus 1 minus L. And then I have to mod this one by 558. So mod this one by 512. Oh, this one. So this is the number of 0 that I have to add between this one. And then this number is 448 is come from 512 minus, we have to add 64 digit, and then another number 1 here. That's 1. Oh, equal sign. So this is 447. 447 here, which is the same here. Okay, so this is the how much 0 I need to add. So repeat 0 by this digit, and then bi and 1 and something at the end, which is 64 digit of binary on the L. So this means I have to go and base of L by base 2 64. Get this, and then the total length here will be length of this one 512. So this is the first one, and at my first try I missed something because at some point the number will be like, if I go like longer one, ABC, okay, not enough, will be longer this one. And then my first trial I failed to do this one, but thanks to Thomas that I find out later that I have to split this one into 2 sections, which is it have to be like mid this one by length of this one divided by 512, and then when this one. So this means this I have to split into 2 block here, and this is 2 block, and then the number to start, which is 512, then the length of this one is 512. So I have to meet this one into 2 points, and then the length of each block will be 2 of 512, but I will deal with that one later. So let's start with the simple one, ABC. Okay, so after this gonna be headache here. Now we have another set of hash, initial hash, which is all this number. So I grab this one, put it here, grab, and then I only need the number after equal sign space, so I can go with regex with call of regex extract this one after equal sign space, but I don't need that one, so reset this one out with k, and then number or digit and take off. So these are the number in hex base 16. I can change this one to hex to dex with this one plus sign. So these are the constant we need. Then this is where everything get complicated. So where is it? H1. Okay. So I have to do this. We have to do M. So the first M will be the something from this one, which is I have to go read 412. I have to go back here. 412. So I have to operate each one in 32-bit, and then I also again I quite lost on this one, but at the end this 512 have to separate into 32-bit, so it means this one divided by 32. I have to go 16 digit each one here. This means I have to go mid this one by sequence of 16, and then step every 32, and then length 32. So I got this kind of block here, which is 1 to 16, and this 1 to 16 will be used here as the as the first starting. That's it. Wait, here which is the first M. So this will be M from 0 to 15 or 1 to 16 here, and then the rest I have to do this operation. This means I have to do this one based on WT minus 2, which is T will be start from 16 if we start from 0, or 17 if we start from 1, and then minus 2 means this will be, so let's say we start from 16 and then we need 17 minus 2. Oh wait, 1 minus, okay, just go minus 2, and then this one not operation, just use it, 7 and then 15 and then 16. Wait, okay, so this means from here sequence of 16, when I'm at position of 17, I have to grab this one 15 and do this operation, plus number 7, which is minus 10 here. So this will be minus 7. I got to grab this 2, and then this is the minus 15, but have to do this operation and then minus this one. So at this one, number 17, I have to grab this part and then do some calculation. Same, if I'm go at position of 18, I have to grab the next one, which is 16 and 11 and 3 and 2 to do all this operation. Oh, this is quite long. So I think I'm just gonna use what I already done here because I think too much to talk here. So, okay, so this one is I already done here. And the way I use is I go with reduce. So I think this one, WT. So okay, this one. So this is the after I got this one, I turn this one into decimal. So decimal. Decimal. This one will be base 2. I've got this number. So this is okay. I think I'll just grab this one. Okay. And then this part is what I do here, decimal. And then there are some function which is this one by 0, which is again it have to go back to that function called here. Where is it? Here, which is I think I'm not gonna make it. So which is this 0 is from rotate to the right of W minus 15 here, and the number of chip is 7, and then again with number 18, and then chip to the right with 3, which is just in of 2 power by 3. So this is the sigma, small sigma 0, and then this is small sigma with 1, and at the end everything have to go XOR. So this is again, so this is number 2 with 17 here, 19 and 10. So this is 17, 19, and chip to the right with 10. So, and then this is not gonna complete this one because I have to define function. So this is the constant, which is W, and that W is the full digit, which is 32, and then I use 2 power 62 32 a lot, so this is to be FW here and another cross here, and then I need the function to do this rotate, which is this one. So this is the rotate function to the right, and require this one to be bit chip left, no, bit chip right here, and then bit chip left with W minus N, and have to mod at the end here. Okay, so go like this. So at the end, when I add this number one by one, so this one will become operation of bit chip to the right, and then on number 15, I guess, and then bit chip to the that operation. I don't want to continue this one. Okay, so like all this, and this one will return 64 WT here. Okay, so it's like really complicated. So that's it. Okay, so this one is this. Return me the WT, and then after I got this WT, I have to do the hash, which is initial with this one, and this one will be A, B, C, D, E until H here. So this is the initial, and to calculate initial I have to do this sigma, this kind of operation when t equal to 0 to 63, which is basically all this. And the operation will be this sigma with e, and the sigma again will be that function to do that rotate to the right something. Okay, I think I have to refer this one a lot. I'm just gonna print screen this one. Copy. Okay, so set. Mhm. So this new calculation, this one will be the h, which is the number 7, last one here, which is this one h, and then have to do this sigma from the e, which is number 5. So this one will be a, b, c, c, d, e, f, g, h. Okay, so I have to do this sigma based on b, which is this function rotate to the right. Sigma 1 rotate to the right with 6 time, rotate to the right 11 time, and then 25 time. And then this function, which is ch, so this will be bit end of e and f, and then not bit not of x and z, which is g here, and then k will be constant number on that number, which is start from 0, and the constant is here. This number start by first one, and then wt is this one. So the first operation will be like t1 will be the h, which is this one, plus that rotate TOR on this E, and then this rotate inside we have to do that. No, this is sigma. So sigma have to do this all rotate here, and then we have to do that CHE, which is plus CHE on EFG. So this one be EF and G, and then plus with K, which is the first one on the constant, which is this one, and then plus the first one on this one. So this is the first time we got T, and this one. Okay, just go with text here. First time, and then we calculate T2, almost the same. We just have to follow, and then we reassign A to H again with this one. So A will be T1 plus T2, and then B is the shift of A. So this means on the second round, this one will be T1 plus T2, and then this will be A. So this one equal to A, and this one will be equal to B, and D will be C, this one, and then the E will be equal to D, and plus of T1, and T1 is calculated here. So, and then F will be E, so this G will be F, and H will be G, so go like this, and then we get rid of this one out, this, and then the next round have to continue like this and go on until I complete 64 times to this one. So I did that here. So we have, I run up with this one, WT plus K, which is this term, WT plus K, this term, and then this one is sigma 0 sigma 1, and then that's ch, which is a bunch of XOR, and that's MAJ is used for T2 here. And now I got T1, which is this one, H plus that sigma 1 plus CH plus W, which is the short term of W plus K. Then this one is the sigma 2 here. And at the end, so this is A, T1 plus T2. And then B will be A, C will be B, D will be C, and then this is all this term, and then complete. So first round here, and then I have to run for 64 times, which is all this. And then at the end, I will get the A to H, and then A to H have to plus back on the hash 0 again, which is HA here. And then this HA refer to the constant from the beginning, which is this one. Oh, so, and then at the end I will get okay, so I think I'll just grab this one. I think I have already done it here somewhere. Okay, so this is the part where I got WT, and then this is the part where I got, yeah, so I got the process on this one past the HA, which is this. And after I got this one, I have to turn this one into hexadecimal, which is base 62. Oh, base 16. So deck to hex here. And I have to mod this one to limit the digit of number into 8 digit. 8 bit for each character here. And then to cut this one. So this is the final result from this one. Okay. So at the end, I got all this into one formula, and then I turn this one into lambda, which is this one, which is A. So now we can check this one on the website that do all this stuff. So this is the website I'm talking about. They have a lot of things here. This one is 256, and then this is the text I test, but without the alternate enter here, so I have to minus this one. And then this is the result I got from this, which is this one on chip V. And then this is the function I got, so I can check if it's the same. So if this one equal to what I got from that one, so this is true, so it means my function is working good here, but except that I use this function hex to dec is return capital. If we want small letter, I can go with lower, this one, but doesn't make any significant change here. Yes. So this is like, now I got this one, and then when I got this, I can do the same with 2 to 4, which is just changing of some constant. Guess. Oh no, the constant are the same, but the hash initial hash is different. Guess somewhere. It. Okay, so the initial hash is different, but the calculation method is the same. But at the end, we will only need, so this is for 256, we get all from 0 to 7, but for 2 to 4 here we only get from 0 to 6, and then the length of this one will be less by 8 digits. So if I, this one plus 8, 64, but this is 56, And I can check this one. Okay, this. So okay, wait, I have to copy all this and this. So we got 184, 174 here. I got 174, and the rest should be the same here. And then I continue with the HHA one, which is not exactly the same. They require some different calculation, which is where is it? Start with the constant. The constant function is also different. So this one is calculate based on t here. So different t, like just like we have 1 to 64 before, and then 1 to 64. First 16 is calculate is from something, but the rest is do different kind of operation. But this one, every 20 digit here require different calculation. And then the constant is also different. So this one, first 12, oh, first 20 is this one, the next 20 is this one, and then the first one. So the constant of this one will be 80 row. This one is 64 row. So this is the different. And then the calculation is also a bit different. So this one, the first 16 is grabbing from all this similar, but this one is used rotate to the left with 4 number. So I done this one here. So instead of rotate to the right, I have to do rotate to the left, which is this function here. And then WT here, I have to go with this rotate to the left. XOR here somewhere. Okay. Oh, XOR on T minus 3. Where's it? Okay, minus 3, minus 8, minus 14, and then minus 16, which is here. And now the initial hash, we have only 5 here, initial hash. So this is the initial 5 hash from the document, and then the rest is just do the calculation and rotate this to get everything. So finally I will get all this, which is can compare to the online stuff over there here again. And I don't know if I have some more energy later, I will continue with that 32-bit, but that's gonna be a lot different because I cannot use the built-in function, which is this one, bit and bit all here. I have to go on by my own. So just for starting, I'm just trying a little bit here. So okay, let's try a little bit. Okay, let's grab some number from this one. Grab some constant here. That's it. Wonderful constant. Okay, just grab this two. Okay. Just extract this one. U plus 1. So I got to call here. Now with this long, I cannot turn this one to decimal. Cause oh, I can, but it will not show all the digit because the the rest of the digit becomes 0, so I will not get accurate result here. And then so I have to turn this one straight into binary. It means this is hexadecimal, so each digit is 4 digits of binary. So this means I have to go with mid. Let hex to be this one. Then the mid hex with sequence of length of hex by 1. Get hmm? Oh, hex here. And then I have to turn this one into binary. And then before that I have to turn into decimal. So next to deck here. Next to deck here. And then have to turn this one to binary. Small number is good. So by deck to bin. The EC to bin. But I need fixed digit which is 4. So this one be 4 and concat everything back. So to deal with this one, I have to go with this. And then if I have to go bit and here, I have to check each digit here. So mean if I have let A is this one, B is this one. Assume these two are the same length here. This mean I have to go with no. Assume this one have different length. I have to fill out into the same length. So max of length. So x will be max of length A and length B. So this will be my x 64. And in case of this one have different digit, I have to fill out 0 before this one to get this digit. So I mean right p0 by x and A by x. Good. Okay, so this is like fill out the 0 before if some of this one have less than that digit. Okay, I'll reset A and B. Fill out at the same time, and then now I have to check each digit if it's equal to 1, and then if this is for bit n. So it means I have to go mid. Better go with S stack. Go with S stack. And then I can like mid this one by sequence of x by 1. Got this, and then equal to 1. Now I can by what? By row and get true false minus concat. So this is bit n. So I have to go this much. Bit or I have to go like or this one, and then bit XOR I have to go like this XOR, and then bit not I have to swap each digit. Bit not is require only one digit, so I have to swap that. Okay, just A, and then I don't need X is length A only. Oh, I need max digit, which is okay. X is max digit. let's say how much? 64. So I have to go with mid. Okay, mid of, wait. Yeah, I need to fill out and then just a here. Okay, wait. Mid. Okay, right. Just go with this one. Fill out digit and then I have to go mid on this one. Okay, just swapping. So sequence of x by 1. Now if it's 1, I have to go 0. If it's 0, go by 1. So I can go 1 minus each digit here and then concat. Okay, a bit. Now this is bit not of the first one. Okay, let's check by I equal to this. So just swap digit. So this is bit not. Uh, XOR or and then shift left and shift right. It just add 0 onto the left or onto the right. So okay, left, shift left, F, L shift, then shift. L shift will be, let a this one and then n, let's say 2 digit. This means I have to go with a and repeat of 0 by n. And then I want to keep only 64 digit, which is I have to go with right by 64. So this is the bit shift left. And then bit shift right will be add 0 to the right and then get rid of the leftmost digit, which is almost the same here. Except that I have to go this one, but this, and only keep the left digit. So left. Huh? Oh, so this is the chip right, and then after this I have to go to do that rotate left and rotate right using this one instead of that bit left bit right here. So first step is to do this one, bit chip left bit chip right, and then continue with new set of operation. So this is the new constant on the initial hash. Then the calculation will be somewhat different. Where's it? Here. Oh, it used the same. No? Where's it? When read until this point before. The exact the same is 512, or I have to read 512. Oh, this is 512. So these are the new calculation, new operation on WT. Okay, and then new operation on the A to H here, and then the rest is the plus and minus. Which is quite similar to this one, except that I have to use this instead of the bit. So which I think I'm gonna do it later and then add back into this one. So if you like this one, you can download this one, and the link is in the description. Okay, that's gonna be all for today. So thanks for watching and have a nice day. Bye.